Okay, hello, this is Dr. Janes, and today we're going to talk about using a ultrasonic distance finder, this guy right here, with our Arduino Uno, and maybe add it onto our robot eventually, our Bobot robot. But probably in this episode we'll just look at trying to program this guy and measure distances. It says it can measure distances up to, I think it was 4 meters, and with a resolution of 0.3 centimeters. Is that right? And so this should be a pretty interesting device if it can really measure distances that accurately. Yes, it says 0.3 centimeters and runs at 400 kilohertz. And let's see, detection distance 2 to 450 centimeters. So 450 centimeters is 4.5 meters. So it's going to be a pretty interesting device. Add some sight to our robot. Okay, so our sensor here that we've started to put together on our robot, actually we're just going to put it on a board above the robot, I'm not going to put it on the robot, but is a HC-SR05, and here's a data sheet for it. It's not made by this producer, but I believe it's a similar sensor, and it says that you put out a trigger pulse, and then the sensor will send out a ultrasonic burst, and then it will wait for the echo to come back, and your Arduino actually has to measure the length of this pulse. And so you could probably write a program to do that, but it looks like someone has already written a library for that. Here's one called newpin, and I haven't tried it yet, but he claims it works really great, and there's not a lot of lag in the libraries, and it can do multiple sensors possibly, and he's got some examples here, and here's a download for it. Okay, so that link there takes us to to a download repository, and it looks like there's some different versions here, and so I guess we'll just go with the newest version. If I remember correctly, I believe that the Arduino library importer will import the zip file directly. It's been a little while since I've done this, but we'll download the newpin hopefully into downloads. newpin.zip. Okay, and so it's definitely there. So if we go into Arduino and update some of your libraries, include library, add.zip library, I believe this is how it's done, and under downloads, newpin. Okay, and I think that's all you have to do. I believe that the newpin library is now loaded in, so maybe we can start writing sketches and see if we can get our Sonar device here to work. Okay, so now we have our this is our Arduino IDE up, and if we go down to examples, and so now it has newpin, so the libraries did load successfully. And I was looking at I believe it was newpin example, and let's make sure this is focused right. And actually what I was doing is I was modifying it, because this is a short little program, and it uses the trigger pin and the echo pin. And let's see, newpin Okay, so here's my modification of it. So what I did is I wanted to, since the robot actually uses pins 13 and 12 for the communications, the EZVR, there's a conflict with those, and it uses 11 and 10 for the servos. I wanted to see if this works on 9 and 8, and actually it does seem to work. Let's take a look at what we're doing down here. So these are the pins that I'm talking about. Okay, so here we have an Arduino Uno up here on top, and see, I have it plugged into, normally the program will require it to be in 12 and 11, which is up here a little bit further, but I've plugged these into 9 and 8 to see if it works, because sometimes there's some different things on the other pins. And here's the voltage pins and the return, the plus and minus voltage. And if we look at the sensor down here, here's our sensor and our Arduino. Okay, and we look at the pins on the back of the sensor. We have the red one going to VCC, which is the far left. The black one's going to ground, which is the far right. And then we have the yellow one going to right next to the red one, right here. Okay, and then the white one going right next to the yellow one. And then the one right next to the black one is actually open, which is, I believe, output. Let's see if we can read the pins. I believe it was Echo is the yellow one. Is that right? Yeah. No. Yes, Echo is yellow and it's on pin 8 on the Arduino, and the trigger is on pin 9. Okay. And I have this program loaded into memory, and so we have our, of course, USB cable here. And we can plug that into the back of the Arduino. We have it sitting on top of another Arduino, so I don't want them to electrically communicate or short out. So we will put some cardboard in between them, and I'm starting to integrate it onto the robot. So if we go into, of course we want to make sure that the port is selected, so we'll go into that and select that, and we'll turn on serial monitor. And I notice I had to select this. This one's actually set to what is this? 115.2 kilobaud, and you can change the baud settings. The other ones I was running at were 9600. I don't think it makes too much of a difference, but so if we put our hand out in front of here, we'll notice that it's actually measuring 19 centimeters, and then we bring it closer, and it'll measure about 10 and 9, bring it up 7, 6, 5. So it looks like it's working, but it's also putting a bunch of zeros in there, and I don't really like that. I'm moving my hand further away, and it's measuring farther distances. Let me refocus. So now it's like 30. We'll move it up close, and it's about 4 centimeters. It's putting a lot of zeros in there, so I was thinking about changing the program, because it looks like it's measuring properly, but I don't like those zeros in there, and maybe just putting some if-then statements to take those zeros out. I also, for this example, I slowed it down. This delay was like 50, and when it's going that fast, the numbers are kind of a blur. And so I was looking at maybe doing some averaging, and maybe averaging 4 points, and then printing out the average, because here see the serial print has actually got the get program, gets the number, and so it's lost once you put it into the print statement immediately, but I made some variables and was saving them into them, and I have it commented out right now. But if we just uncomment this stuff, and this is not taking out the zeros right now, but oops, that's what I'd probably like to do, is write some algorithm that skips those zeros. We'll load this one in. Okay, it's going to run a little bit slower, but it's going to have averaged, and of course it's averaging some zeros in there, so it's still getting some weirdness. But we move it closer, move it further away. It's a little bit more reliable number now, and so I think we can use this to have the robot avoid obstacles, and that will be a neat feature. And looks like the sensor's working pretty good. They're very inexpensive. They're about $5 or $6, and it's pretty cool looking. This is the what was it? The SR. Let's take a look at this guy. I forgot the name of it. So it's HC-SR05, and I believe that they all work kind of about the same. There's minor improvements, I think, in the different versions. So anyway, this is Dr. Janes, and thanks for watching.